let's start. So shush. Thank you, thank you. Thank you. Please don't make me say I'm starting shush twice. People on the internet are going to freak out here. Ready to go? The goal of this lesson we wrote is to make connections between the coefficients in a polynomial function and the constant in the polynomial function and what they look like on the graph. So some of the key terms are going to be the constant term, the leading coefficient, and the degree. Now recall the degree was the highest power of x, or whatever you're using as the variable, but usually for a generic graph, we're using x. As an example, suppose we have a function that looks like this. F of x equals 2x cubed plus 6x squared plus 7x, take away 3. Okay. First thing that I would like to identify is what's the degree of this polynomial function? 3. Why? Right there. That tells you what it looks like. That tells you, without graphing, don't write this next bit down, that the graph either looks like this or looks like that. In fact, I can even tell you more specifically, I know it looks like this. Now, why do I know it looks like that? Well, that comes from the next thing I'm interested in, the leading coefficient. What's the leading coefficient? And I love the way that you said positive 2. The fact that it's positive tells me, much like a line that has a positive slope looks like that, a positive x cubed graph is going to go like that. It may have the little bumps in the middle, but it is going to go start on the bottom left and leave the bottom right, top right. And then we have the constant term. What's the constant term in this question, in this example? -3. And what does the constant term tell you? Well, it also tells you the y-intercept. In other words, if you asked me really quickly, and I'm not going to right now, so don't write this down, but if you said, hey, sketch that graph, I would go like this. I would say, okay, it goes through -3, and it probably does something like that. Or maybe it does something like that. Or maybe it does something like that. I do know it has to go through a y-intercept of -3. I do know because it's a cubic graph, it's going to be curvy. And I know because it's positive, it's going to start bottom left and end bottom right. And we'll talk about, well, to determine more than that, really you need either calculus, if you're going to do it by hand, or we have technology, our graphing calculators, which you probably are going to need, so you might want them out if you don't have them already, to figure out the rest. So let's look at a linear function. Suppose we have this. F of x equals 2x plus 1. We'll zoom in a little bit. Okay. What can I tell you from this? Well, first of all, hopefully you can tell me the y-intercept. Help me out. With me, Kayvon? Yeah. You with me, Seb? Because you had some kind of shared interest there. Focus up here, right? Oh, Justin. Sorry, what am I doing? Seb sits there in my other class. Confused for some dumb reason. Justin, tired, can you tell? Yes? You awake? Yeah. Am I awake? That's the real question. What's the y-intercept here, Justin?
1.
Thank you. Good recovery. Hey, what else can I tell from here? Well, I can probably tell you the slope. What's the slope here? Positive or negative? If we were to graph it, we would say, okay, starts here, goes up 2 over 1, up 2 over 1. This is math 10, hopefully. Looks like that. What else could I ask you for or ask you to tell me about? Well, we had something that we called the domain What's the domain of this? Well, we said for any line, as long as it's not straight horizontal or straight vertical, those are the exceptions. For any other line, the domain is going to be all reals, and the range is going to be, range, Mr. Dueck, don't use X. Range, Mr. Dueck, use Y. What else could I ask you for? Well, we talked about the end behavior. And by that, we meant moves from quadrant what to quadrant what. So I'll go scroll up for a second. Let's go from left to right. So starting from the left, as we move across, what quadrant does it start in? Okay, so we need to remember that this is quadrant 1, 2, 3, 4, and it looks like it moves from quadrant 3 to quadrant 1. And the last thing I can ask you, and by the way, for a linear graph, it's a bit more boring. I can ask you for a number of turning points. Zero. Okay. I'm going to compare that with a slightly different graph. I'll do it the second, skip the middle one so we have kind of some blank space, but I'll do another one here instead. Let's look at, well, we just use f of x, so how about we'll go g of x, and let's say that's negative 2/3 x, oh heck, minus 2. And I'm going to now zoom out a little bit so I can get this all on one page because I want to compare kind of the different pieces of information. And you're going to notice, Rosanna, hopefully a lot of it is the same. There's only a few tweaks, and we can recognize those from the equation without graphing. What's the y-intercept here? Negative 2. What's the slope here? Negative 2/3. If we were to graph this, we would put a dot at negative 2. We would go down 2 over 3, down 2 over 3, and then we can back count like that. What's the domain? How far left, how far right does this graph go? Yeah, all reals. In fact, you know what? Let's draw that in red a bit later, but those two are going to be the same. Range, y is all reals. Those two are going to be the same. The end behavior is going to be a bit different. What's the end behavior here? moves from quadrant what to quadrant what? Sorry? Quadrant 2 to 4. And again, if you said it goes from quadrant 4 to 2, I won't take marks off, but just so all of our answers look the same, let's decide, Jake, that we're always just going to read from the left to the right. So wherever it appears coming from the left to wherever it leaves going to the right. Just so we have some kind of convention. Oh, and number of turning points is what? 0. Which of these are going to be the same for every single straight line as long as we exclude vertical and horizontal? So I'm going to, anytime I'm talking about a line, let's assume I'm not talking about a slope of 0 or an undefined slope, unless I specifically say, which of these will be universal? Well, I guess those two, those two, those two. Which of these are influenced by the leading coefficient? Which of these can you tell just by looking at the leading coefficient? Right? The leading coefficient tells us this. Okay. Also, the whole positive negative slope thing. So we're trying to find some universalities for lines. And we're trying to say, Emma, I mean, it's nice if I have to graph it. If I have graph paper, fine. But I'd kind of like to see if I can do at least some of this in my head. Some of it, clearly, I can't. Let's go to a quadratic. I think turn the page for you folks, yes? F of x equals x squared minus 2x minus 3. X squared minus 2x minus 3. Put your pencils down for a second. Last year, you learned in Math 11 how to handle a parabola. You learned this. If I said y equals negative 2 bracket x minus 3 all squared plus 5, you said, oh, that has a vertex of positive 3, comma, positive 5. Remember that? We called this standard form for a parabola. You said, oh, I know that this opens down. Remember that? But that worked for when we had it in standard form. I didn't give you this one in standard form. I gave you this one as x squared minus 2x minus 3. Now, last year, I think you learned a process called completing the square. Does that ring a bell for some of you? Where you learned how to take this and turn it into y equals ax minus p all squared. Make it look something like that. And the process went as follows. You said, okay, the minus 3 temporarily moved over. You divided that by 2, which was worth a negative 1, and then you squared it, and you subtracted it. And then you kind of said that factors into x minus 1 all squared, and then you said, oh, that's a minus, Mr. Dueck. Then minus 4, and you could, okay. I'm not going to be assessing that this year, Ellen. I'm going to say for now, do we have graphing calculators? We're going to use the technology. So even though my heart of hearts, Seb, wants you to be able to graph these by hand, it's Math 11, and I'm not going to reteach it. And also because there is no quick, easy way to graph the cubes anyways. So since we're using the graphing calculators for the cubed ones, oh heck, let's use the technology. So get out your graphing calculators, please. And go to your graph menu and clear any graphs that you might have there. Delete any graphs that you might have there. You there, Jacob? You okay?
My calculator's like xt1 and then yt1.
So what you want to do, give it back to him, Roy. He needs to know how to fix this. Press, look up, F3, which is type, and make sure you're a y equals graph, F1. Okay? There's all sorts of different ways to graph. So you were in what's called parametric equations, which are very useful in advanced physics. Great, okay, but we're not going to talk about that here. You cleared your graphs? Oh, and before we graph, let's go to our standard view window, which is Shift F3 and standard, which is -10 by +10, -10 by +10. Everybody there? Kayvon, you there? Yeah? Justin, you there? Yeah. Okay. And then press exit to get back to the graph menu. And type in, anybody not there? Type in this equation. Type in this equation. I'll pause the video for a second to go help people. Oh, to do what? View window is in yellow right above the F3, so Shift F3. Don't use a pencil. Use your, it wears off the paint on the buttons faster. Thank you. And then view window, STD stands for standard, not what you've been taught. Okay. And now type in the equations. Remember, this is your X button. Common mistake when kids start doing this is they want to use this as their X button. That's actually a different X. That's a function X, which is, don't use that. So X squared minus 2x minus 3. Yep. Why? Could you have done that like 2 minutes ago when I started? Hurry up, go, 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 please. Actually, stay here. I think I have one for you. Do you have a phone to trade with me? Yeah. Okay, give me a second. And then when you've got it like this, hit draw. And ideally, all of us should have a similar screen. Yes? I don't know if I typed mine in right. Hang on. Yeah, x squared minus 2x minus 3. Yeah, okay. Is that right? Okay. If I'm going to use my graphing calculator, well, first of all, without even doing any math, without even graphing, I could have told you the y-intercept. What's the y-intercept of this graph? So I'm going to put a dot right here. It's going to go through there. What's the other point I'd really, 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 really like to find? You there okay, Jacob, or not? Yeah? Okay. What's the other point I'd really like to find for a parabola? The vertex. How? That's going to be G solve, which is F5, and it's either going to be a maximum or a minimum. It depends on whether your graph opens up or down. So you'll just have to interpret. You'll have to clue in. In this case, which one is it, Jake? Maximum or minimum? The vertex. Minimum, right? And you guys are in grade 12. Minimum means the lowest. Maximum means the highest. So min. Vertex is at 1, -4. Right there. What other points would I like to find? What do you think? The x-intercepts, which are called what? Roots. Now, if they're decimals, they won't be very useful, but I'm hoping these aren't. There you go. We have an x-intercept at -1, 0. Oh, and how did I find the second x-intercept? Right arrow. Another x-intercept at 3, 0. You can, if you want to, find more points, and the way to do that is if you go to the G-solve menu and then go arrow sideways, like that, you can do a y calculation. A y calculation says, if you give me an x, I'll give you the y calculation. So if you go F1, you might say, hey, when x equals 2, what's another point on this graph? 2, -3. You know what? I've got the shape. Looks like this. Yes? So what are some questions that I can ask? Can I ask you for the slope here? Well, no, that doesn't make sense. It's a curve. So what can I ask you? Certainly I can ask you for the y-intercept. And we said the y-intercept equals -3. What's the leading coefficient here? It's a bit of a trick question, but what is it? +1. What does that tell you? Well, certainly you guys learned last year that it tells you the parabola opens upwards, and hopefully you also learned last year that it tells you that this parabola hasn't been vertically stretched at all. Having said that, since we're using graphing calculator technology, that second part isn't that crucial. The first part, though, Rachel, I will expect you to know by glancing at a parabola whether it opens up or down, whether it's a maximum or minimum. What else can I ask you for? Now, the roots, technically, you can find using the quadratic equation, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. But you know what? Since we're going to be, for the most part, typing these in, you can also use the technology. What were the roots? -1, 0, and? Okay. What I'm probably going to ask you, because it's kind of plug and chug to get the roots, I may not ask you for the roots. Instead, I may just say, how many roots are there? In this case, there are 2. By the way, how many roots, we're going to go to this middle graph for a second, how many different roots can I have? So I'm going to write here number of roots for a quadratic. Well, clearly I can have 2 roots. There's an example of a quadratic with 2 roots. Can I have no roots? Yeah, how? You know what? If the range is either opening up and everything above 0, or opening down and everything below a number less than 0. So you know what? How about there's an example of one with 2 roots. Sorry, with no roots. Can I have 1 root? Which point begins with the letter V and rhymes? Okay, so I could also have 1 root if I had something like that. So I'm just going to make a little note here. You can have 0, 1, or 2 roots. By the way, for a straight line that we just looked at, how many roots will I always have? 1, unless it's one horizontal, but we're not talking about those. Number of roots of an equation, 1. By the way, what's the degree of a linear function? What's the exponent on the x there? It's invisible. How many roots? 1. What's the degree of a quadratic function? What's the most number of roots that you can have? Care to guess what the most number of roots you can have for a cubic function is? 3. Care to guess what the most number of roots you can have for a quartic function is? 4. One of the reasons the degree is so important, it tells you when to stop looking for roots. It doesn't guarantee you have 4 roots, but it says if you found 4, you can quit. Or if it's an x to the 5th equation, if you found 5 roots, there are no more. Could be fewer, but good, he needed that for some strange reason. Okay. Back to our graph. Domain. All reals. And this is what some of you are having trouble with, so I'm going to slow down a little bit. What about the range? So how do we, first of all, range, y or x? Okay. What I want to show here is that it's everything above and touching -4, that vertex there. How can I write now, in English, I guess I could write, Cole, everything above and touching -4. That's way too much. So we say it this way. First of all, above, would that be greater than or less than? Greater than. If it's below, less than. By the way, if you get them mixed up, look up for a second. I've remembered it this way for years. What capital letter does that sort of look like? L for less than. That's red less than, okay? The whole bird alligator thing, that whatever I've never understood that whole mouth, whatever, that didn't work for me. Anyways, L for less than. So what's the range here? All y's above, and then that there means or touching, -4. What quadrant does it move from? What to what? What's its end behavior? Moves from quadrant 2 to 1. Then we did kind of a comparison. In the last line, we looked at a negative slope. I'm just going to do a kind of a little sketch. I'm going to say, hey, what if you had something like that? I just made that one up. Okay? What would be the same here, whether it opens up or opens down? First of all, how do you know whether it opens up or opens down? What can you tell me about this black graph that I just drew? Okay, let's make a little note here. Leading coefficient is negative. Roots, it all depends. This one has 2 roots. Kayvon, I could have drawn one with no roots or 1 root. Here's what else. What's the domain? Still all reals. What about the range? Well, y would be less than or equal to, and I'm just going to write here the highest point, the vertex, the maximum. Now, this one moved from quadrant 2 to quadrant 1. How will this one move? Quadrant what to quadrant what? Moves from quadrant 3 to quadrant 4. And then the last thing, for any parabola, how many turning points? What we're going to be doing in the homework is we're going to be saying, hey, sketch a graph that has this many turning points that goes from this quadrant to this quadrant. Hey, what kind of an equation must it look like? Here's 4 equations. Pick the one that it might have come from. And you'll have to use a process of elimination. Cubic functions. Remember, cubic functions have degree 3. As an example, f of x equals let's go with 2x cubed plus 6x squared minus 5x minus 4. I think we better start right now with graphing this, but we're going to try and look for some patterns so that we can avoid graphing this if necessary. So go to your graphing calculator, hit exit to get out of the graph that's in there. Delete the equation that you have, get out your graphing calculators, and type in this one. Okay? Delete the equation that you had there and type in this one. By the way, look up. I want to show you an obscure error that some of you have been getting. So if you've typed in the equation and then you hit draw, you get this weird condition error. Do you notice, although I have this equation typed in, the equal sign box is not shaded in? What's happened is I accidentally deselected it. This F1 means select, and so your graphing calculator is saying, you didn't give me a graph to graph. So if I go up here and hit F1, now the graph has been toggled on, now it's been toggled off, toggled on, toggled off. You do want to make sure your graph is toggled on. So if you're going, I think I've typed it in right, Mr. Dueck, but nothing's appearing, that's one obscure error that I've seen, that I've helped a few of you with already. If you hit draw, uh-oh. What do you see here? I'm going to need to adjust my view window. So I'm going to go F3. Am I low enough? So I'm okay with that. What I'm going to need to change is my Y maximum. Everything else looks okay. My left and right looked okay, and my bottom, how low I went looked good. Take a guess, and I'm purely guessing here. How high should we try? 20? Okay. I'm going to put Y max of 20. And now I'm going to hit exit draw. Oh, that's pretty good. I might have been able to get away with 15. I don't know. Okay. Certainly, I do know one point on this graph. One point on this graph is y-intercept of -4. One, two, that's not far enough, Mr. Dueck. Okay. The rest, I'm just going to get the shape. So looking at this, looks kind of like this. Goes up, comes down through here. Is that right? Pretty close? And because this graph paper here doesn't really match my scale, I'm going to label the key points. So the y-intercept I already said was 0, -4. I'd like to find this one here. I'd like to find that one there. And then I'd like to label the roots. If I do that, then, Rachel, I have a pretty good idea of what's going on. So how can we find this top point up here? G-solve maximum. Because that's a turning point. Yes? I'll go -2.35, comma 14.9. Is that okay? I'll go exit, oh, sorry, G-solve minimum. Thinking. 0.35, comma -4.9. 0.35, comma -4.9. Oh, and I'd like to find the roots. G-solve root. -3.5. -0.5. (1.1), I guess, if I round off to one decimal place. Is that okay? So, information that I could ask you about. How many roots? Three? By the way, how many roots are possible? Well, you can either have a graph that looks like this, or you could have that same graph do that. How many roots are possible with a cubic? How many here? 3? How many here? 1. Can you think of a way where I could only get 2? Okay, I can also get 2 if I have... Let's try that a little closer. There would be a way to get 2, so I can have 3 or 2 or 1. Can I have none? I can have none? That's number of turning points, but it's still got to go through the x-axis somewhere, doesn't it? Because think about this. Any cubic graph starts bottom left and leaves top right, or starts top left and leaves bottom right. You're always going to have 1. In other words, unlike the parabola, 0 is not an option. There's always, for a cubic graph, at least 1 root. So let's make a little note here. Number of roots, 1, 2, or 3. What else can I tell you about a cubic function? Well, if I look at the leading coefficient, I'm really not that interested in the number. What I do notice is that it's positive. It's positive. Look up. There's a positive leading coefficient right here. If I go to this same graph and I just put a negative in front, starts on the top. You know what? This almost looks like a negative slope, like with a line. And when it's positive, it looks like a positive slope with a line. And that is true. So let me get rid of that. Where's my delete? The fact that it's positive means that this moves from quadrant 3 to quadrant 1. If it was negative, it would go from quadrant 2 to quadrant 4. Oh, the y-intercept, -4, or -4 comma 0. Okay. Domain, all reals, and range, all reals. For every x cubed graph, Rosanna, they either do this, which means they go all the way left to infinity, negative infinity, all the way right to positive infinity, all the way down to negative infinity, all the way up to positive infinity, or they do this, which means they're still doing the same thing. In fact, what's the degree of a cubic function? 3. What's the degree of a linear function? 1. For any odd degree function, they're all going to look like this or look like this. They all have domains and ranges of all reals. So, number of turning points in our case. Two. What did I say? 3? Because I'm thinking cubic. 2, thinking degree. So, let's try this. Turn the page. says determine the characteristics of each function using its equation. So we want to answer those 6 questions. Okay? Here's our first function. How many possible x-intercepts are there? First of all, what's the degree of this function here? 1. What kind of graph is a degree 1 function? Linear. So how many possible x-intercepts are there? Sorry? Right? Because it's either going to do this or it's going to do that, but it's got to cross the x-axis somewhere. What about the y-intercept? -5, yes? What about the end behavior? What does this one look like? Moves from quadrant 3 to quadrant 1. Right? I mean, we're visualizing that it looks kind of like this. What's the domain? All reals. What's the range? All reals. And what's the number of turning points? Number of possible turning points? None. None. That's a line. Let's try something a little more interesting. B. Okay. You know what? Let's do a little sketch of this over here. Which way does this... first of all, what kind of a graph is this? It's a quadratic. Which way does it open, up or down? What's the y-intercept? Okay, so if it has a y-intercept of 8 and it opens down, it's got to look something like that. I mean, it may do that, or it may do that. I don't know. But if it's got a y-intercept of positive 8, it's got to go through there. So how many roots, how many x-intercepts must it have? This one has to have 2. Can't have 0. Can't have 1. It's got to have 2. What else? What's the y-intercept? We already answered that. What's the end behavior? Moves from quadrant 3 to quadrant 4. Domain? All reals. Range? Y is less than or equal to, hey, whatever the max is. And if we went to graph this, we could, but we're trying to see how much this we can do in our heads. So wherever the vertex is, it's everything less than or equal to wherever the vertex is. Right? And, number of turning points, 1. Trickier one. Hey, what does this graph look like? First of all, can you tell me the y-intercept of this graph? Okay, definitely goes through -10. What's the degree of this graph? 3? Is the leading coefficient positive or negative? Positive, so it's going to move from where to where? Okay, you know what? It's going to do something like that. Or maybe it may do something like this, or it may do something like that. You know, I can tell you the number of roots is going to be 1, 2, or 3. I need to actually see the graph to be more specific. So let's see. What can we answer? Number of x-intercepts? 1, 2, or 3. Y-intercept? -10. End behavior? Where to where? From quadrant 3 to quadrant 1. Domain, this is boring, all reals. Range, this is boring, all reals for any odd degree function. A little more interesting. Number of turning points. Could it be 1? Maybe. I'm going to say probably 2. We'd need to graph to be certain. Okay, let's do a little matching. Match, it says, each graph with the correct polynomial function and justify your reasoning. I'm going to shrink this down a little bit so I can get this all on one page. Okay. Hey, you know what? Let's do this by type. Let's do all of the linears, then all of the quadratics, then all of the cubics. And we'll cross stuff out as we go here. So what letter, G, J, P, H, K of x, or Q of x, which of those is the first linear graph that we run into up here? Which of these is a linear graph? Sorry? None of them are linear? I disagree. I totally disagree. I think 2 of them are linear. No, just looking up here. What's the first linear graph? Okay, h of x. Let's see if we can go find that. What can you tell me about h of x? First of all, what's its y-intercept? And slope, positive or negative? So which graph has a negative slope and a y-intercept of -3? Uh-oh. They both do. Okay, let's go look at, Rosanna, you with me, please? Let's go look at the other line. What's the other linear function equation? What's the other linear function? Right here, q of x? All right. What's the y-intercept of q of x? You know what? The y-intercept isn't going to help me. Positive or negative slope? That's not going to help me at all. You know, I'm going to have to just go by the magnitude of the slope. Which of those two graphs would be steeper? H or Q? Because 2 is a steep, H, 1/2 is a steeper slope than 2? No, 2. I think 2 is a steeper slope, because that would be down 2 over 1. So I think we can safely say that's graph Q, that's graph H. You know what? Let's not cross them out because you'll want to look at those later in your notes. Okay? Let's deal with the parabolas now. Where are the two quadratics, the two parabolas? I think right here and right here. Yes? Guys with me? Okay. Which way do both of these parabolas open, up or down? So that's not going to help at all. What's the y-intercept of each of these? Negative, oh, that'll help. I'm looking for one that has a y-intercept of -2. You know what? That's graph J. That's graph K. Now let's look at the cubic functions, the x cubeds. Looks like we're looking between G and P. What's the y-intercept of this one here? -2. What's the y-intercept of this one here? Okay, that doesn't help me at all. Let's go look at the leading coefficient. Leading coefficient here, positive, here, negative. Okay, positive, P of x, which is positive, is which one? Graph 5 or graph 6? Because going up this way. I can safely say that's graph P. Sorry, that's graph, P, and that's graph G. Process of elimination. A couple more, we're done. In fact, last one, I think we're done. Oh, no, 2 more, we're done. It says, sketch a possible function for each characteristic below. All right. Ta-da. Let's do a sketch. What have they told me here? I'll do the domain and stuff later. Y-intercept -4. Y-intercept, like I said, +4. What else have they told me? Well, they've told me the range. They've said it's all y's such that, remember I said we can just kind of ignore that for now. It's saying y is bigger than or touching -2. So there's -2. It's everything above that. What's a possible graph that satisfies this? Could this be linear? Could this be quadratic? Possibly. Could this be cubic? Could this be cubic? No, it's got to be a parabola. And, okay, I'm not sure where the vertex is. The vertex could be here. The vertex could be there. You know what? I'll just put kind of the vertex there. It would look something like this. So I can tell you a fair bit of information. I can tell you that this is a quadratic. I can tell you it has to have degree 2. Yep. Yep. I can tell you the lead. Hey, the leading coefficient here, must it be positive or negative? Oh, I can tell you the constant term is what? What's the constant term here? 4? Lots of information. One more, we're done. All right. The range, oh, hang on, turning points. You know what? Again, let's do a little sketch here. Turning points, there's one in quadrant 3, another in quadrant 1. And the range is all reals. It's a cubic, and what must it look like? I think it has to start in quadrant 2, and I think it has to leave in quadrant 4. That's the only way that I can have turning points in those locations. Okay. Try those. Make sure you're checking your answers in the back. We're using the textbook a bit more for this unit, so make sure you're checking your answers.